last lesson on sequences and series, and we're going to finish off this this combined sort of cumulative revision exercise. This one we asked to find Tn in simplified form. Well, if we go that minus that, right, we get minus 3/4, and if we go that minus that, we get minus 3/4. So in fact, this is an arithmetic sequence with d equals minus 3/4. Remember our formula for the nth term of an arithmetic sequence? Tn is a plus n minus 1 lots of d, right? So the nth term here will in fact be a, which is our first term, plus n minus 1 lots of negative 3/4. Right. If we take the brackets out of this thing and simplify, we actually get negative 3/4 of n plus 21 3/4. Okay, so reasonably straightforward question, maybe just made a little bit more difficult by the fact that we've got some fractions. It then says, show, and this is a little tricky, it says show that T29 minus n plus T29 plus n is equal to 0. All right, so what we're going to do is we've got a formula for Tn, T29 minus n, we're just going to put into that formula, instead of n, we're going to put 29 minus n. Right? And then we're going to add this piece. So exactly the same. Into that same formula, we're going to put T29 plus n. All right, so this is going to be negative 3/4, 29. Sorry, I've actually forgotten. We've also got this piece here, so that's 21 3/4. Right, all of this stuff is just that bit. Okay, all I've done is I've put 29 minus n in place of the n in this formula. Now what I'm going to do is I'm going to add, and I'm going to do exactly the same. So it's going to be negative 3/4. But instead of putting 29 minus n, now I'm going to put in 29 plus n. All right, and I've got the plus 21 3/4. All right, and we're going to kind of look at all of this. Okay, and what we get, this one actually simplifies to negative 87 over 4 plus 3/4 of n plus 87 over 4. And this one too, minus 87 over 4 87 over 4 minus 3/4 of n and plus 87 over 4. Right, and in fact, if we look at this, we're clearly going to end up with 0 because these two are going to divide out, or cancel out rather, and these two are going to cancel out, and so are those. So we end up with a final answer of, we end up with a final answer of 0 as required. Right, a little bit abstract and technical, but not impossible. Right, next one is sigma notation, and by now we're hoping that you're totally comfortable with the trick with sigma notation is to write down our first three terms. The first term of this is minus 2/3. Remember, sigma notation always means add. The next term is 2 over 4, positive 2 over 4. The next term is negative 2 over 5. Right, okay? We are in fact only adding those three terms, right? Because we're putting in 3, we're putting in 4, we're putting in 5. This thing is not arithmetic it's also not geometric, all right? And so we're just going to add them manually. We can use a calculator, all right? And we will end up with negative 17 out of 30. Just to show you how we would do that without a calculator, just while we're here, let's choose a common denominator that they all go into. They, in fact, all go into 60. To make this fraction equivalent to 60ths, I've multiplied the bottom by 20. I'm going to multiply the top by 20. Negative 2/3 is exactly the same as negative 40 over 60. 2 over 4, I've got to multiply the bottom by 15 to get to 60. So I must multiply the top by 15, and I get 30 out of 60. And then lastly, to get 5 to 60, I need to multiply by 12. So I'm going to multiply the top by 12, and I get 24 over 60. All right. This actually is minus 10 minus 24. It's minus 34 over 60. Lastly, I can look for any common sort of factors of 34 and 60. And in fact, 2 goes into both of them. If I divide the top by 2, I get minus 17. And if I divide the bottom by 2, I get 30. And that's what the calculator would have given us. Okay, but really important that we're not scared of fractions. This question, as I said, involves a variety of different sequences. If we just look for pattern here, in terms of the gray triangles, they're going 2, 4, 6. It looks like the next one is going to be 8. The white triangles are in fact the perfect squares. 1, 4, 9. The next one is going to be 16. So A is 8. B is 16. And then these ones are going up by 2, then by 4, and in fact then by 6. All right. We can obviously, we can just count the triangles. All right. That's how one's meant to do it, but we're starting to look for a pattern already. All right. Now it asks us for simplified expressions for all of these. All right. So X is actually going to be quite easy. It's just twice, if we go and have a look, it's just twice as big as the diagram number. All right. The white triangles are, in fact, the diagram number squared. So X is just 2n, whereas Y is n squared. Now Z is a quadratic sequence because Z starts at 0, then it goes to 2, then it goes to 6, then it goes to 12. If we look at the first differences of this, right, the first differences are 2, 4, 6. Right, and if we look at the second differences, we in fact get 2 and 2. Remember that A is half our second difference. So A is in fact going to be half of 2. A is going to be 1. We then know that 3 lots of A plus B is going to equal our first term of our first differences. It's going to equal 2. So we've in fact got that 3 lots of 1 plus B is 2. So in fact B is minus 1. And then lastly, we know that A plus B plus C is equal to the first term of the whole thing. We know that A is 1. We know that B is minus 1 plus C, and we know that that must come to 0. So in fact, C is actually 0. So our final answer is that for Z is that the nth term is 1n squared minus 1n. Okay. Right. Let's look at the next question, which is in fact asking us which diagram has 1,260 black triangles. Now we've just worked out that the nth diagram has got n squared minus n. So we're going to make that equal to 1260. This is a quadratic equation. We could use our quadratic formula, or we could try and factorize it, right? I'm going to factorize it, but I must admit that I used the quadratic formula to find the answers in the first place. So it's actually n minus 36, or n plus 35, right? And therefore, Obviously, n can't be negative. N is always a natural number. So in fact, the 36th diagram will have 1,260 black triangles. Now, the next question, and this is a little bit of a strange one, it asks us for the nth term of this sequence. Now, this, if we look, this is not arithmetic or geometric, right? But in fact, it's only one mark. And the numerators are quite easy to generalize. They go 4, 8, 12, 16. They are just the multiples of 4. So the nth fraction will just actually have 4n on the top, right? And if we look at the denominators, they're just one bigger than the numerator. So it's just going to be 4n over 4n plus 1. That will be the nth term, right? And that's unusual and not necessarily all that straightforward. Right, question 12 says, which term of this sequence is equal to 163, right? What sort of sequence is it? Is this minus this the same as this minus this? Yes, it is. This is an arithmetic sequence with d equals 7. We're adding 7, sorry, d equals plus 7. We're adding 7 to get from one term to the next, right? We are asked now which term is equal to 163. So we're going to use our term formula. Tn is a plus n minus 1 lots of d. And we get 163. A is minus 5 plus n minus 1 lots of 7. Right? And let's add 5 to both sides. We get 168. Is 7 lots of n minus 1. When we divide both sides by 7, we get n minus 1 is 24. So in fact, n is 25. Right, so the 25th term, right? Remember, we could write that like this. T25 equals 163. Okay, and then I think it's the very last question indeed. Determine this value of n. How many terms must we add up to get a total of 896? Remember the deal with sigma notation. We're going to write down 3 terms. First term is 5, the next term is 7, and the next term is 9. Right, now we know what we're dealing with here. And so we've in fact got 896. Okay, so what we've established now is that this is definitely arithmetic with a common difference of 2. We know our sum formula for an arithmetic sequence looks like this. N over 2, 2 lots of A plus n minus 1 lots of D. Right, and I know the answer is 896 when I add up all these terms. I don't know how many terms there are. I do know that the first term is 5. And I do know that the common difference, D, is 2. Okay. If I now multiply both sides by 2, I get 1792. And I then get n. And if I simplify what's in the brackets here, I actually get 8 plus 2n. Right? Let's multiply it out, and I get 2n squared plus 8n minus 1792 equals 0. I can divide all the terms on both sides through by 2. And I can either use a quadratic formula or I can show you the factorization. The factorization is actually n minus 28, n plus 32, and the final answer just n equals 28. And that brings us to the end of this topic of sequences and series. I think it's a nice topic. I think it's one that you can do well on. But remember that there's no substitute for doing plenty of practice. All the best.